In the last video we've done analysis of our lovely bracket. We got to the solution, but there are things that we could have done better. Let's see how. The first thing you might notice is that these two bunny ears or clamps or whatever you call them, they are opening. And if you imagine a shaft going through the holes and the bushing between them, they should stay at equal distance. So how to model that? To apply force we have another option. Let's suppress this one and use remote force instead. The way to define it is the same, but Ansys now adds some kind of interaction between scoped areas, and this can be defined under behavior. If we select deformable, this gives the same results as previously. But if we select rigid behavior, now we assume that those four selected faces are rigid, and that's exactly what we need. With this option we get desired behavior and max stress is just a bit lower. Now to the second problem. You see part of bracket at some places acts as if there is no support underneath. So to model that better, we could use displacement tool and choose Y deformation to be 0. But even better is to choose compression only support. And how's the deformation now? Ooh, that's better. And stresses now are even a little bit lower. And now to the last challenge. It is mesh. We haven't given too much thought in the last video, but it's important. Let's see how maximal stress changes when we change resolution of the mesh. The easiest way to increase number of nodes is to go to mesh and increase resolution in the details. So, how is the convergence? When we go with a resolution from 0 to 7, 0 being the coarsest mesh and 7 being the finest mesh, we get plot like this. On x-axis we have number of nodes and on y-axis we have max stress. What we would like to have is a curve that flattens at the end. This one doesn't seem to. Resolution goes only to 7, so if we would like to increase resolution of mesh, we can try with another method. Let's try refinement. Here we can also select only certain areas to be refined, so it doesn't make additional nodes where we don't need them. This option has limit of refinement of 3, whatever that means, and at the end still we get not very good convergence. So let's try with another method. It's called sizing. Here we also define faces on which finer mesh is desired, and then define approximate element size. Let's also select slow transition. With this option, face sizing, when we go with element size as low as 0.1 millimeters, we get more than 5 million nodes, and it takes quite some time to get results, but at the end we get very good convergence. So what is von Mises of the converged model? It's 24.5 megapascals, and the initial model from the previous video we had 25.3 megapascals. Close you might say, but actually this was another model. There were some different boundary conditions, and after defining remote force we got 22.6 megapascals, and after adding boundary conditions we got to 20.6 megapascals. And then after doing convergence analysis we found out that it's actually 24.5 megapascals. So it seems that the two errors got cancelled out by each other. And this is not always the case, and sometimes the two errors will add up. So I suggest you try out different boundary conditions and force applications so you see how the model behaves. Also, I urge you to always perform convergence analysis so you know whether you can trust your model or not. This is my advice. Hopefully this video series was helpful to you. If it was, support me by liking it. If you have any ideas for future videos or questions, write down in comments. And if you want to be notified when new videos come out, then subscribe.